Hello, this is Rick from MathX, and today we'll be solving number 29 of the 5th 6th grade Math Kangaroo of 2018. Now this is a number 29 on a 5th 6th grade test, so that means that this is probably one of the hardest problems on the test. However, while this problem is not easy by any means, it's actually really fun to attack, and once you get the trick to it, this problem just falls apart, just like a lot of other Math Kangaroo problems. However, that's the part that most people struggle on. So that's why I'll be demonstrating how to solve this problem and show you the trick that really unravels this problem. So without further ado, let's just get straight into it. There are 8 domino tiles on a table. Picture 1. One half of one tile is covered. The 8 tiles can be arranged into a 4x4 square, picture 2, so that the number of dots in each row and column is the same. How many dots are on the covered part? So for the information of this question, they basically give us a picture of dominoes, with one of the dominoes being covered, about one half of the domino being covered, and it tells us that we can arrange all these dominoes on this 4x4 grid such that the sum of the dots in each column and row is the same. And using this information, it wants us to find what the covered region of the domino is. So the first way we can attack this problem is just by thinking a little bit. So if each of these columns and each of these rows have the same number of dots when all these dominoes are placed, well, that's an interesting thing to think about. That would mean that the sum of the dots in this column, and this column, and this column, and this column, and this row, and this row, and this row, and this row, they would all be the same. And we realize that the sum of the dots in each of these 4 columns and 4 rows, well, each of these dots will be counted twice. It'll be, this square could be counted like this along this row, or like this along this column. So that already sets up for something interesting. Furthermore, if the sum has to be equal in each of these 4 different rows and 4 different columns, the total number of dots has to be able to be divided into 8 different groups. But wait, it doesn't have to be divided into 8 different groups, because remember, each of these columns and each of these squares is going to be counted twice. So let's say the sum of all the dominoes on this thing is x. Then we get that 2 times this value of x has to be divisible by 8. And just to recap what I did there, in each of the columns and each of these rows, each of these squares is counted twice. 1 in each column, 1 in each row. And we can say that it has to be divisible by 8 because the sum of all these dots will be counted twice in each of these columns and each of these rows, but will also have to be distributed into 8 different groups in each of the 4 rows and in each of the 4 columns. So we can see how many dots we already know for them to exist, and we can see if this satisfies it. So just looking at the number of dots here, we can count up the number of dots already visible and try to use this to predict how many dots are on the part that we can't see. And then we can use it because let's say the number of dots here is a couple off from being divisible by 8. Then we realize since it works, it has to be divisible by 8. And we can use that to infer the number of dots on the hidden part. So let's just tally up all the dots for now. And then this is the number of dots that we can see. And to find out the number of dots we don't know, well, we don't know that for now, but let's just represent it as D. We know that the sum of all this times 2 has to be divisible by 8. So now we just need to add it up and see what value of D will make this possible. So these are a lot of numbers, but you can go through it just pretty easily because it's just addition. So we get the number of dots and the number of unknown dots. Well, we get this value of x to be equal to 37 plus d. So then if we multiply by 2, we get 2x to be 2 times 37 plus d, which would give us 74 plus 2d. And we need this to be divisible by 8. So let's think about it. What's the closest multiple of 8 to 74? It's 80. Now, 80 is exactly 6 away from 74. So 6 is equal to 2d, meaning that d is equal to 3. Now, why can't we have other numbers in there? Because there's another multiple of 8. There's 88. However, if we go to 88 and we subtract it, we see that 2d would equal to 14. And then if 2d equals 14, d is equal to 7. And we can't have 7 dots on one part of a domino. And this indicates that the number of dots must be 3, as this is the only value that works. So to recap, we realized that twice the number of dots in the entire grid would have to be divisible by 8. We summed up all the dots we knew with the dot we didn't know, used some slick algebra to plug it in, and we realized that it can only be a multiple of 8 if d is equal to 3. So, just by using some simple algebra and just creative thinking, we beat this problem, a number 29 that looks quite intimidating with all its dominoes and grids. But the kicker in this problem was just to realize that in order for the sum of the dots in each column and each row to be the same, it would have to be a multiple of 8. And then once you realize that, the rest of the problem just falls apart.